number 1. The second digit that means green numbers represent the natural numbers. Fact number 2 is the sum of every nth row is equal to 2 power n. Fact number 3. Every row is the power of 11 when concatenate the numbers. Fact number 4. It is the symmetric triangle across xy plane. Fact number 5. The sum of diagonal represent the Fibonacci sequence. Fact number 6. Sum of consecutive numbers are square numbers. Fact number 7. The third diagonal represents the triangular numbers. Fact number 8. Each row of Pascal triangle represent binomial coefficient in the binomial expansion.
The Haliuta-Pascal triangle is a triangular array of numbers built as follows. Every row begins with a 1 and ends with a 1, and every other entry in the triangle is obtained by adding the 2 entries directly above the entry in question. We can fill in the rest of the triangle using this pattern. Here, we've only pictured up to row 7 in the Haliuta-Pascal triangle. Now let's go through this triangle and shade only the odd entries. We get a picture that looks like this. But if we zoom out to show 256 rows of Pascal's triangle and shade only the odd entries, something amazing happens. We produce the Sierpinski triangle.
Implementation of Pascal's triangle. Pascal's triangle is a pattern of numbers in which the first and last numbers of each row are 1, and every other number is the sum of the 2 numbers immediately above it. Here's an example of the first 5 rows of Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. In C, we can generate Pascal's triangle using a nested loop. Here's some sample code. Let's break down what's happening in this code. We first triangle. We then prompt the user to enter the number of rows they would like to generate and read their input using scanf. We use 2 nested loops to generate each row of the triangle. The outer loop runs rows times, and the inner loop runs from 0 to I, where I is the current row we're generating. Within the inner loop, we check if we're at the first or last position of the row, i.e., j == 0 or I == j. If we are, we set coef to 1, since the first and last numbers of each row in Pascal's triangle are always 1. If we're not at the first or last position of the row, we calculate the current coefficient using the formula, I, j plus 1, / j, which gives us the sum of the 2 coefficients above it. We then update coef to the current coefficient. Finally, we print out coef, followed by a space. After printing out all the coefficients in the current row, we print a new line character, \n, to move on to the next row. Once all the rows have been generated, the program returns 0 to indicate successful completion. I hope this helps. Let me know if you have any further questions.
ਡੱਬ ਬੱਤੀ ਬੋਤਲ ਕਾਲੀ ਕਾਰ ਨੀ ਮੇਰੇ ਡੱਬ ਬੱਤੀ ਬੋਤਲ ਕਾਲੀ ਕਾਰ ਡੱਬ ਬੱਤੀ ਬੋਤਲ ਕਾਲੀ ਮੇਰੇ ਡੱਬ ਬੱਤੀ ਬੋਤਲ ਕਾਲੀ ਕਾਰ